All right, this is Algebra 2, Unit 7. Going to go over quizzes here. We'll start with the Day 5 quiz. Basically, we're working with sequences and they're arithmetic and geometric sequences. So let's just jump right in. We got number 1. Is this a sequence arithmetic? And if so, identify the common difference. So the common difference would be the difference between any two of the consecutive numbers. So let's take the first two numbers, 14 and 21. What's the difference? Well, the difference is 7. Let's take 21, 42. What's the difference? Well, the difference is 21. Okay, so those are not the same. Okay, 7 does not equal 21, so the answer is just no. It is not an arithmetic sequence, and that's it. Okay, so let's look at the second one. Find the arithmetic mean of find the arithmetic mean an of n minus 1. That means the term that's before that. Okay, this term comes before this one here, comes before this one. Okay, an minus 1 is 5/7, and an plus 1, which is a term after this, is going to be 9/4. Well, how do you get the middle one? Okay, well, if it's arithmetic, you're going to find the arithmetic mean. You just take the average of those two. You just add them and divide by 2. So you take 5/7 and add 9/4, and we got to divide by 2. All right. So now it's just the math. You can add the fractions, get the common denominator, divide by add and then divide by 2. If I divide by 2 now, I'm going to get 5/14 plus 9/8, and then I do common denominator then, and I'm going to get 20 56ths plus 63 56ths, all right, which is going to give me 83/56, which is my answer. So that's the arithmetic mean of those two numbers. You just add them, divide by 2. Okay, number 3. Grocery clerk sets up a display of 12-pack cartons of cola. There are 15 cartons at the base of the triangle and 1 at the top. So how many cartons of cola are needed to complete a display? So he wants to display a 15 on the bottom, and he wants to make a perfect triangle out of it. So it's like bowling pins. You know how they're set up? You got 1, and then 2, then 3, and then 4. Each row adds 1 more. So you get like pyramid, all right? And you're going to see something interesting here. In the first row, we have how many? 1, right? In the second row, how many are there total? You have to add up all those. That's 3. Okay, in the third row, you have 6. In the fourth row, you have 10. All right. You'll see that in each row here, okay, that number is the same as how many are on the base of, so far. So on our fourth row, we have 4 cans, and we have a total of 10 cans if we count all the ones above it. Okay? So what can we do to figure out 15? Well, we can add them all up, or we can use a formula. All right? So in our formula, we have, to find any term, okay, it's just n, because, first row has 1, second row has 2, and so on and so forth. So when we want to get a sum, we want to get a sum here. So the sum is going to be, we want how many cans on the bottom? We want 15. So Sn is going to be n over 2 times the A1 plus our last term. Okay? So what we do is just plug in 15 for n. So sum of 15 cans on the bottom is going to give us 15 over 2. What's our first term? Our first term is 1, right? So it's 1 plus, what's our end? It's 15. So in the end what we get is S15 equals 15 over 2 times 1 plus 15. And so that's 15 over 2 times 16. We can cancel out there. That'll give us 15 times 8, which will give us 120 cans. So when you have 15 cans in a row kind of stacked like this, 15 cans, just pretend I got 15 there, 15 kind of, it's all stacked like that, And of course, this is using 5 on the bottom just for space. But, all those you can add up just by using a formula like that. And that's what we're talking about here. All right? Because it adds 1 each time. So 1 and then 2, 3, 4, 5, and so on. Well, what's the total? And that's how you find it. Okay. Number 4. Describe the pattern in the sequence. Find the next 3 terms. Okay, we have 4, 8, 16, 32. Okay, so the pattern right off is going to give, times 2, right? Every term, you multiply by 2 to get the next one. So the pattern is multiply by 2. All right, that's the pattern. Now, what's the next 3 terms? Well, for the next 3 terms, we just multiply by 2, and we get 64, 128, and 256. I'm not going to bother with formulas right now because we just get the next 3 terms and we're fine. Okay, so that takes care of that. For the next one, we got 625, 250, 140. Okay. So again, it wants the same thing. It wants the next 3 terms, and it wants basically the rule. What are we doing here? Well, if you divide this out, you're going to get 2.5. And then between those two, you get 2.5. So the rule is divide by 2.5. And to get the next 3 terms, we just keep on dividing by 2.5. It's pretty simple. So we're going to end up with 16. Divide that by 2.5 to get 6.4. That should be a decimal. And then divide that again by 2.5, and we should get 2.56. And that's our answer there, and that's our rule. Okay, 2 parts to that problem. Number 6, write a recursive formula of the sequence 8, 10, 12, 14, 16. Then find the next term. Okay, so remember, recursive means it has to do with the prior term, so it must have this in there somewhere, a n minus 1. That means you have a n is the term you want, a n minus 1 is the term previous to that term. Now, what's our common difference here? It's 2, right? 2, 2, so it's the arithmetic sequence. So our arithmetic sequence is going to be a n equals a n minus 1 plus our common difference, okay? The common difference here is 2. So we're going to drop 2 in there, and we get a n equals a n minus 1. That means the one before it. Let's see if I can write that better. Sorry. A n minus 1 plus 2 is our formula for the sequence. So that means to get, say, the third term, you take the previous one and you add 2 to it, and that'll give you the next one. Okay, so then find the next term. Well, we had a n minus 1 was 16, so the next one you would just add 2 and you get 18. So our next term is 18. Oh, we also have part of the recursive formula is that we'll need the first item in there. So first number in the sequence is 8. So our actual recursive formula is a n equals a n minus 1 plus 2. but this is also part of the answer. Our initial number is 8, and then, of course, the next term is 18. All right. The next one is explicit formula for the sequence 7, 2, -3, -8, and so on. And then it wants to find wants us to find the 14th term. Now we can go over and do this 14 times. What you're really doing is we're subtracting 5, right? Subtracting 5 each time. All right, and we can do it. We can keep subtracting until until we get to the 14th term, and then we finally find it, right? Well, one thing you can tell, it's going to be a negative number because it's going to keep going, decreasing by 5. We're already at -8. We want to find the 14th term. Okay, but it asks for a formula. So remember, it's an arithmetic sequence. The formula for arithmetic sequence explicit formula is AN equals A1 plus and minus 1 times D. All right, D is a common difference, so we already know -5 is D. So let's write this formula out. We have AN equals, what's A1? That's going to be 7. That's our first term. So 7 plus N is any number, minus 1, and then D is -5. Sorry about that. -5. So now we can distribute this -5, right, over this parentheses, and I'll show you what we'll come up with here. So AN equals 7 plus n minus 1 times -5. And so let's distribute that, so that equals -5n, and the -5 times -1 is going to give us +5, and then we just tack our +7 on the end there. You'll notice that these two can be combined. So our AN is now -5n plus 12. All right, that's our explicit formula for finding any term. So the 14th term, we just substitute in 14 for n. A14, the 14th term, is going to be -5 times 14 plus 12. Okay? Multiply that out. It's going to give us -58. And that is our answer. So instead of having to write out everything, right, out to the 14th term and trying to find out what that is, we could just make a formula, and then we could put anything. You could find the millionth term if you wanted to. All right. Next, we have table shows predicted growth of bacteria. So your hours, are in, and your number of bacteria. So we'll just put the number, the total bacteria that we have. So after with 1 hour, we got 19. After 2 hours, we get 38, and you kind of see how this is going. 3 hours, you get 57. So it's adding 19 every time. So what kind of sequence is it? It's arithmetic, because you're adding the same number every time. Okay? So the number of bacteria is just 19 times the number of hours. And that's it. All right, it's explicit formula. I mean, we could do the whole, AN, equals A1 plus n minus 1 times D, but I don't think we have to do all that because we know that's just times 19. So, I mean, at this point, we could stop. I think it's because it starts at 1. It doesn't, the first number we have is 1. It's 1 hour. Okay. So next one is number 9. The formula AN equals -4 n times n minus 1. Is that going to be explicit or recursive? Remember, recursive means that it depends on the number before it. Like A, you're going to see an A n minus 1. Okay? So that's not there, so it's not recursive. It is explicit. That is our first answer for that. And then it says find the first 5 terms of the sequence. So what we can do is take this, an equals negative 4n times n minus 1. Okay, we could find our first 4 terms by substitution. Okay, so we have a1, a2, a3, a4, okay, and a5. I need that too. Okay, so what's a1? Well, the first term is going to be, we put 1 in right there for n. So it substitutes there and also there. Now, just do this in your head. 1 minus 1 is going to give you 0, so 0 times anything is 0. So the first term is 0. Okay, and we just do the same for 2. We substitute 2 in for n. Negative 4 times 2 times 2 minus 1. And that's going to give us negative 8. And then do the same thing for 3. Substitute 3 in for n here, and that's going to give us negative 48. And then substitute the 4 in there. That's going to give, I'm sorry, the 3 is going to give you negative 24. Sorry about that. And this is going to give you negative 48. And the fifth term is going to give you negative 80. If you just, all you're doing is substituting 1 through 5. And you just have to do the math to get that. That's all. Okay. The number 10, find the 50th term of the sequence. 5, negative 2, negative 9, negative 16. Okay, and that keeps going. First of all, what kind of sequence is it? All right, well, between 5 and negative 2, you have, it subtracts 7. And it subtracts 7 here. And there it is. Okay, so it's an arithmetic sequence, obviously. So again, you apply your formula for an arithmetic sequence. An equals the first term plus n minus 1 times the common difference. Common difference is a negative 7. So we do have to include the negative because we're decreasing. All right? So it's important. It's not just 7, it's negative 7. And we want to multiply this out. N equals 5. Negative 7 times n is minus 7n. Negative 7 times 1 is positive 7. So those two numbers will combine there, okay, to give us an equals negative 7n and plus 12. All right, so that's our formula, and now all we have to do is find the 50th term. So what's going to be our 50th term? Well, a 50 equals, and just substitute 50 in for n. And if you multiply that out, that's 7 times 50 is 350, right? So negative 350 plus 12 is going to give you negative, and so you got negative 338, and that's the 50th term of this sequence. And you got it really quickly. Okay. Now, number 11, find the missing term in the arithmetic sequence. It's important that it says arithmetic, because that means you find the arithmetic mean to get that, which from before we just add these two terms because they're to the right before or right after the missing one. That's important. And we just divide by 2 because it's going to give us the term that's in between. It's right in the middle. And that's going to give us 56 over 2, which is going to be 28. Okay? And that's our answer. 28 goes right there. 28. All right. And one more, I think. Number 12, find the arithmetic mean an of an minus 1 equals 3.9, and an plus 1 equals 7.1. Okay, so still, again, you have the third term there, you have the first the first term, as far as these three go, an is going to go right in the middle. So what's the middle term? It's arithmetic. So again, 3.9 plus 7.1. We divide by 2 because that'll give us our arithmetic mean. And we actually, if we add those, we're going to get a whole number there. That's going to be 11 divided by 2. And that's the answer. You can say 11.2. You can say 5.5. You know, whatever you want to do. Okay, so answers in your test. If this were a test question, you might look for either format, improper fraction or decimal. And that's quiz 1.